So let's discuss a problem from GATE 2021 physics, and this is from classical mechanics. So this is related to block M, which is of that is block of mass M and another mass attached to it, and a string of length L, and also finding generalized momenta. So this is the problem. So a uniform block of mass M slides on a smooth horizontal bar. So this is the block of mass M. So it is of uniform mass is distributed uniformly, and it is sliding on smooth horizontal bar. This means we should neglect frictional force acting on the bar. So that is the meaning of this. Next, another mass M is connected to it by an inextensible string of length of negligible mass. So this is another mass which is attached to this block M through this string of length L, and is constrained to oscillate in xy plane only. So this mass oscillates only this xy plane. That means like this, from this side to that side, that's it, but not back and forth, front and back like that. So next, neglect the sizes of the masses. So here we should neglect the sizes of the masses. The number of degrees of freedom of the system is 2. So here they are saying the degrees of freedom of the system is 2. And the generalized coordinates, that is the distance of the block from the origin, that is one of the degrees of freedom, and this angle theta, this how much angle is this oscillator making. So these both are enough to define this system at a given time. So only 2 degrees of freedom. So and the generalized coordinates are chosen as x and theta as shown in the figure. So these are the generalized coordinates, and if px and p theta are the generalized momenta corresponding to x and theta respectively, then the correct option is, so here x and theta are generalized coordinates, then px and p theta are the corresponding generalized momenta. So we need to find out what is the correct option. That means here we need to find px and p theta. So from that we can have some conclusion. So here coordinates of capital M mass. So block of mass M, its coordinates are nothing but it is at a distance x from the origin, along the x-axis, and along the y-axis there is no motion for this. So it is sliding along only along x-axis. So its coordinates are x comma 0. And next, coordinates of M. So this is M. So its coordinates now we have to see. So for that, so this is a string of length L. Now if we draw a perpendicular from the here, so this is from the center of mass point, you can say. So now this looks like a triangle. So this entire thing, that is this looks like a right angle triangle. So now from this, cos theta is nothing but adjacent side by hypotenuse. Hypotenuse is L. So we would get this is L cos theta is L cos theta, that is this side is L cos theta, and this is L side theta. Along the x-axis it is L sin theta, and along the y-axis it is L cos theta. So now the coordinates of this small m is nothing but actually from here to here it is x, from here to here, it is x, and if we add up this part, that is nothing but L sin theta. So it may add up or it may subtract. So if the mass is on this side, so it would add up. If it is on this side, it would get subtracted. So it depends on theta. So sine of minus theta is nothing but minus sine theta. So like that you can see. So the coordinates, x coordinate of this mass is nothing but x plus L sine theta, and the y coordinate here is, so this is positive y axis and this is negative y axis. So as from here to here, that is nothing, so this is nothing but L cos theta. So it is moving in the negative y axis direction, so its coordinates are minus L sin theta. So these are the coordinates of capital M and small m. So that is the thing. So now V is equals to mgh, that is potential energy of this mass. So it is at a particular height. So we can imagine the potential energy is 0 at this point. At this point potential energy is 0. Then from here to here, mg minus h. So that is nothing but mg minus L cos theta. Actually this is based on this coordinate. So it is on the negative y-axis. So like that. And next, so Lagrangian. First of all, we need to find Lagrangian of this system. So because from that Lagrangian only we can get p theta and px values. So now here the Lagrangian is nothing but T minus V, that is kinetic energy minus potential energy. So in kinetic energy, this block is having only kinetic energy because we have considered the potential energy at this point to be 0. V is equals to 0 at this point. So its kinetic energy is half mv square, that is half capital M. V square is nothing but x dot square. So how this is moving in this direction. So x star with the time, how it's changing. So that is nothing but half m x dot square. And next, this is for the small m mass, kinetic energy. So it is having velocity along x direction as well as the y direction. So because of that, we are having Vx plus Vy because it is constrained to move in xy plane, this mass. So along x-axis, along y-axis, both the axes we are having velocities. And here potential is nothing but V, T minus V. So half m x dot square in the next step. Half m Vx square is nothing but rate of change of x coordinate, that is this. So that's why d by dt of x plus L sin theta whole square. And next is Vy is nothing but rate of change of y coordinate. So here we are having minus L cos theta, d by dt of minus L cos theta whole square. So now in the next step, so this would remain as usual, and here differentiating x with respect to time is nothing but x dot, and applying differentiation on this side. So we are applying differentiation on this side. So here is L is a constant, so it can be kept aside. So differentiation of sin theta is nothing but cos theta. So again theta is also changing with time. This theta keeps on changing with time because this is oscillating. So differentiation of sin theta is nothing but cos theta. Again theta differentiating separately theta. And next is here differentiation of cos theta is nothing but sin theta. L is a constant, so differentiation of cos theta is minus sin theta. So minus into minus plus sin theta, again theta dot and whole square. And again potential as we are having same. So this is the thing we have got. And next, now we need to simplify this. So if we expand this, we will get this x dot square, a plus b whole square, a square plus 2ab plus b square. So that one, from that x dot square and 2 into x dot into L cos theta dot. And next another term what we would get is L cos theta dot square. That means L square cos square theta dot square. This is the another term we are gonna get. And here if we do square of this, L square sin square theta dot square, so both of them would add up. So L square theta dot square could be taken common, cos square theta plus sin square theta, that is nothing but 1. So finally we would have this term, and this is the final term, and this is the thing, and this is potential energy as we have derived, mgl cos theta. And here if you observe, this is nothing but L omega or omega. So here if you see, this string is of length L, and theta omega angular velocity is omega. This is in something like circular motion. So that is v is goes to r omega, just we have like that in circular motion. So here also L omega, L theta dot, so like that it can be. So like that, and this is x dot as usual, and this is x dot velocity and theta dot velocity. So this is the velocity of this. So actually if we see, the direction of velocity for this is this, and the direction of velocity for this is this. So the angle between them, so if we draw a parallel line to this, so the angle would be theta only. So this is nothing but 90 minus theta, and this is theta. So this is velocity of block M, mass of block M. So, and this is velocity of small m particle. So we can just do dot product between those two velocities in order to get the resultant velocity. So that is Vm plus Vm whole square. So if we do that dot product, finally we would get this term only. So like that also we can do this and solve this. So next is now we need to find p theta and px. So here p theta is nothing but, formula for p theta is nothing but dl by dou L by dou theta dot. So if we differentiate here this L with respect to theta dot, what we will get is, so this differentiation is 0 because theta dot term is not there. Here also this term 0, and this term if we differentiate, what we will get is 2 would get cancelled. So ml x dot cos theta would remain if we differentiate. And next is this term also we are having theta dot. So if we differentiate that, n into x power n minus 1, 2 into theta dot, so 2 would get cancelled, and ml square theta dot would remain from this. And here we are not having theta dot term. So this is nothing but p theta. And next thing is px is equals to dou L by dou x dot. So formula for px. So if we differentiate this entire L with respect to x dot, so what would happen is n into x power n minus 1, 2 would get cancelled, mx dot, and here also x dot term is there, so n into x power n minus 1, so mx dot term would remain. Here also x dot term is there, so 2 would get cancelled, ml cos theta theta dot. So this would be neglected after the partial differentiation, and here we are not having x dot terms. So this is the p theta and px value we are getting. So now another important thing is whether we need to find whether they are conserved or not. So if you look at the Lagrangian, there is no x term. X coordinate is absent in this entire Lagrangian. That means Lagrangian is not depending on the x coordinate. So that is nothing but a cyclic coordinate. Then its corresponding generalized momenta would be conserved. That is px is conserved because there is no x term in Lagrangian is not depending on x variable. But p theta is not conserved because here we are having theta cos theta is present, here also theta, so it is depending on theta coordinate but not on the x coordinate, so hence p theta is not conserved. So this is the conclusion we are getting from them. So here the p theta is px is conserved, so that is one of the options, and we need to check out these two options among these two options. So m plus m x dot, so here minus we are having. So let us see what we have got. So here we are getting plus in the middle. So p theta what we have given is wrong. And here m plus m x dot ml cos theta theta dot. So m plus m x dot ml cos theta theta dot. So this is also the correct option. So A and C are the correct options for this question. So is not depending on x. So this is the problem. So thank you.